Hello guys, Assalamualaikum warahmatullahi wabarakatuh and a very good day. So it's just a random vlog so today. So first of all, I would like to introduce myself. My name is Nur Hafiz. You can call me Hafiz. I'm a postdoctoral research fellowship at Sunway University. So today I'm present because today is Saturday. I got open day today. So those who are interested to join Sunway University, actually you can go to the website. They have certain day allocate for open day, so you can browse their courses. If you are interested to enroll in the undergraduates or even postgraduate on the sustainable technologies, you can approach on the website and see potential. If you're capable to see a potential research center to be your mentor or your supervisor in the future. So today I'm just going to brief a little bit about the application or what I did in the lab. So as a postdoctoral research fellow, what I did is I explore quite a few number of application or quite a few number of technology. First of all, that currently my main application or technology is electrochromic supercapacitor. The supercapacitor that capable to change color upon a small potential apply. So basically, electrochromic supercapacitor is almost the same like supercapacitor. In one device, that supercapacitor can change color when you charging or discharging using cyclic voltammetry or galvanostatic discharge. Okay, so by dealing with that, the material itself should have a redox behavior. It's capable to undergo redox process, then you can achieve this dual multi-functional energy storage properties. That number one. So number two, what I'm dealing here is about the lithium-ion battery. So the energy storage in this time in terms of lithium. By having the lithium-ion battery so far, what I encounter is not that difficult, but the whole process to make a coin cell you need to do in the glove box. It's just a little bit tedious, but it's not that far difficult compared to supercapacitor. By right, you're going to measure the specific capacity. You need to have the GCD and also CV to see the behavior of your electrolyte at the electrode-electrolyte interface. So, but the new machine you are incorporating before this for supercapacitor, we are dealing with potential stat. In this case, we are dealing with battery tester. Normally, battery tester also provide current and voltage, but it is more durable because battery you charge at very slow current density. Then it will take a longer time. That's why we need a battery tester. And that battery tester, for your information, can be used to study the stability if you are dealing with supercapacitor. It's quite easy if you're using the battery tester. Okay, that's number two application. So number three, that I try to depth now, maybe my knowledge only on the surface, is about the thermoelectric. So thermoelectric is the application that convert the change in temperature. So we're going to convert heat energy into electrical energy. We call that Seebeck. You can search the word Seebeck coefficient. So from the Seebeck is a principle that can convert heat to electrical energy. Then a lot of things to consider during this, what we call that thermoelectric. We want to know about Seebeck coefficient, electrical conductivity, thermal conductivity, and the ZT value, figure of merit. So by having that, then we have a complete analyzation for the material. Is it material suitable for the what we call it, thermoelectric application or not? Then we move to the device. But the device I just not go depth into that, just surface to study the capability of the material. Okay, that's number three. And if you know me formally, my expertise in during my PhD journey in dye-sensitized solar cell. So in dye-sensitized solar cell, even you have just equipment like potential stat, whatever brand, you connect with the light source, then you can actually obtain the what we call that the main results for the solar cell. So the means result is the JV curve. We got the current versus voltage curve. We want to see from that, number one is the fill factor, the ability of your material to have almost square fill factor, almost 100%. The higher the better. Then we want to have high short circuit current and open circuit voltage. So in the end, by having that, you can generate more power. We call it power conversion efficiency. So that's the main analysis for solar cell. Then if you study the counter electrode, of course we need to study the Tefl plot. Okay, then a lot of analyzation. The rest is the same. We study the cyclic photometry, the EIS is all the same, almost the same with the supercapacitor. So I think by right, the application that I delve into is 4. We got the dye-sense solar cell, then we got supercapacitor, electrochromic supercapacitor, then thermoelectric, and the battery, lithium-ion battery, and now we also want to delve into sodium. My talking about sodium is a little bit difficult because we don't have the separator, the glassy one, glassy electrode for electrode. I forgot the name, but the separator is different because we cannot use the separator used for lithium because the size of sodium is bigger. Might be some of them cannot pass through the separator, so a lot of system didn't work yet by right because of we still get a very low efficiency on that. But as a complement analysis, like supercapacitor, supercapacity also is, I think I can group into one application like electrochromic supercapacitor because all based on the energy storage is quite easy. So I think that's number one. When as a postdoctoral research fellow, I dive into multiple applications and try to understand the mechanism, the working properties, and try to publish a research paper on that. That's one criteria as a postdoctoral. Number 2, you need to join event like this, like open day. You promote to them, the family will come, and you explain to them the benefit to do research here. One of the benefit to do research at Sunway University that I can promote to all of you about the apparatus, about the machine, about the ability for you to do the experiment within the university, sometimes within the center. They provide you a very good facilities. That's why I can guarantee as a postdoctoral research fellow so far, it's quite easy compared to the other university because the facility is great here for research. So I welcome any one of you who interested to join the Sunway University as a researcher, as a student, as a PhD, as a master, and so on. You just need to go to their website and approach your potential supervisor. Okay, that number 2, you need to join the event. Number 3, you need to hold a conference, become a committee, and by right, so far, it's like that. Being a postdoctoral, maybe along the way at other research university, I think the KPI is almost the same. You need to do maybe 80 to 70% research, 20% about admin works, and that's all. Okay, so the next opportunity, I think, for the energy storage field, energy conversion field, I would like to try to see the feasibility to combine both energy storage and also energy conversion into one device. It might be tricky, but we might wonder if it happens, it's good. For example, now we already have photo supercapacitor that combines supercapacitor and solar cell. We might have electrochromic supercapacitor, combine electrochromism with supercapacitor. We might have thermochromic, we might have photochromic, and we might have the integration between thermoelectric and also energy storage. A lot of things is possible. So that's the research that our direction we goes on. And one more thing, because our objective is much more to follow the list of SDG, Sustainable Development Goals. So what we need to do in our lab, we try to reduce the emission of carbon, the amount of carbon we are aligned towards zero carbon 2050, the Malaysian goal. So what we try in this lab, we try also to upcycling. So before this, a very good researcher, now our researcher goes to UTM. If you know from my other video is Dr. Amirul Aizat, he do on the upcycling from plastic waste to nanomaterial, which is carbon nanomaterial, upcycling the rye husk into the carbon nanomaterial. Is quite a good, what we call that, a good approach. When you have a lot of waste, you convert that waste into something useful. That's also one of the direction. And my job, their job is converting from waste to something useful, carbon nanomaterial. My job to implement that material into diverse application. So I think that's all. So I welcome collaboration from all around the world. But what I mean by collaboration, you can approach me and ask something, but don't just simply throw the question without learning or reading the literature. You need to learn, because by having the difficulty in learning, you learn from difficulty. Like you read the journal first and everything, you can get the knowledge. You make the knowledge more precious rather than you just ask and ask. So let me share with you at the end of this video one tips by learning. Okay, to get into new application, for example, you got your PhD work on supercapacitor or supercapacity. A new application need more effort on the learning. You need to read their review paper, the literature review and everything. By that, you sort out what you don't understand, then you approach your supervisor first. Because you goes into your PhD, you must contact your supervisor first. That's the main thing. After that, if you don't understand, then you can outsource, go to outside. That's the better thing. Don't neglect your supervisor. Don't outsource without telling them. Okay, that's the main beautiful thing about a PhD. It is all about learning. Sometimes our knowledge is not that enough to get into that field, then we are asking. So if you have any question, just drop a question on the comment section. If I can answer, I can give an answer. If I not, you need to find another expertise. Okay, that's all for this video. See you again. Enjoy your journey. Bye.